All right. So kind of pick up where we left off. We were talking about confidence intervals. Just to kind of refresh where we were at. I kind of went through some math to give you some support behind some of the thinking I was saying. I just want to be clear because I had a question after class about it. But in a more general context, what we're trying to do, right, is we know that if we have a distribution, right? So kind of jumping right in here today. We don't have anything. I'll mention kind of the homework and things like that towards the end of class. But we're going to start out with this assumed true value for the mean. If I see any sample mean that's within, and here it's going to be a certain critical value. I think the one I chose was, let's assume we're looking at an alpha of 0.05. So that would be a confidence level of what? So I said we can kind of go back and forth. So if I have an alpha of 0.05, we would say the significance level is 5%. The confidence interval would be 95. So what that's saying is, if I see a sample mean, and this is kind of superimposing kind of the standard normal onto there, but if I have anything that's within 1.96 standard deviations of this assumed true value, when I build a confidence interval around that, it will include whatever this assumed true mean is. If, in fact, this assumption ends up being the true mean. Now, how do we build the upper and lower bound? We said, in general, we can write it on one line as I add to get my upper bound, subtract to get my lower bound. We're using kind of the standard normal to approximate these values. We'll dive a little bit more into the student T here today, what happens if we don't kind of use it. But for these two-tailed tests, where we just assume it's equal to a value, and we just want to know, is it above it, is it below, is it anything different than? It's whatever z value or number of standard deviations gives us alpha over 2 in the tail. That's going to be the same value from the standard normal every single time, right? So we're going to see 1.96 pop up every single time we have an alpha of 0.05. We're then going to multiply that by the standard deviation of the sample statistic we're looking at. Now, we know the standard deviation of that sample statistic. We're calculating it using that sample variance over the sample size, or if we happen to have the population variance, we can use it there as well. So to get our lower bound, we're going to subtract what we're going to call our kind of margin of error. And to get our upper bound, we're going to add that, okay? So inherently, if what we're assuming to be true is in fact true, it'll always be the case that my lower bound is going to be less than, right, whatever that assumed true value is. And it's always going to be the case that my upper bound, well, in this case, it's kind of obvious, but I forgot my bar here, is going to be above whatever that assumed true value is, if that, in fact, assumption ends up being true. If it's not, right, anytime I have a confidence interval that doesn't include that, it's likely what I assume to be true isn't true, right? So if my confidence interval doesn't include this assumed true value, if I were to run a hypothesis test, what's going to be the end result? I am going to, so if I have, let's say I assume that the mean is 50, and I run this hypothesis test where I assume that the mean is equal to 50, if my confidence interval doesn't include that, my rejection decision will be that I reject, right? If my confidence interval doesn't include that assumed true value, I'm going to end up rejecting, okay? So that's kind of how these hypothesis tests and confidence intervals are linked. Anytime I end up rejecting that two-tailed test that assumed true value is exactly equal to a specific value, it would lead to a confidence interval from my sample that doesn't include that assumption, okay? And then if my confidence interval does include that assumption, then what's my rejection decision going to be? Well, I failed to reject. I found a sample mean that was pretty close to that assumed true value. So it's kind of where we left off with confidence intervals, hypothesis testing. Once again, I'm doing a kind of a quicker overview. You should have had a lot of this from 370, but especially the terms, I want to get us kind of used to using them again. Okay. Let me think if there's anything else I want to say before we jump back to the slides here. So just to kind of give, well, I'll jump the gun a little bit. All right. So I'll leave this here as I keep going. So what we were doing was essentially saying, okay, look, here's this sample statistic we're interested in. It should be centered around whatever that true population mean is. Now, we don't know what that is, but we've assumed it's equal to something, okay? What we're going to then do is say, okay, let's turn these into, and we were using standard normal values to approximate when we were calculating things like critical values or the number of standard deviations where we need to go. But technically, when we standardize any sample mean that we see from our data, we're going to subtract not the known mean, but the assumed true mean, divide by here the standard deviation of that sample statistic we're interested in. So the standard deviation of our sample mean is the square root of whatever our sample variance is over our sample size. This will give us our test statistic. Okay. So we're going to have these critical values, and here I'll keep kind of running with that same alpha, right? Such that any sample mean I see out here, if I convert it into a test statistic, this is going to be in my rejection region, right? So what's the probability, if what I assume to be true is in fact true, what's the probability I see a sample mean that's going to lead to me rejecting? So if what I assume to be true is in fact true, what's the probability I see something more than 1.96 standard deviations away? Yeah, 5% or a probability of 0.05. So even if I made the correct assumption, what am I going to end up doing sometimes? I'm going to reject even if what I assume to be true is in fact true. We'll call these type 1 errors, right? So there's some slides related to it. I'm not going to go through. It's got some dumb, some, I don't know, goofy examples, but I'm not going to like quiz you specifically on that term. But even if what we assume to be true is in fact true, we might make rejection decisions when we shouldn't be. Now, what's more likely the case, this was such a low likelihood of occurring, that's why we were setting this threshold. We said, look, if the likelihood of what I found falls below 5% or a probability of 0.05, what I assume to be true probably isn't true. What's probably true? The mean is probably somewhere over here, in which case, what would happen to the distribution of our sample means? It should be centered around whatever that true value is. Now, a lot of the times we're not able to observe that, but based off of our sample, we said, look, this assumption, very likely that it's true. It's probably way more likely that the mean is something else. So given our sample, we'll reject this assumption. We can't say exactly what the true mean is, but we know it's probably not this, right? Based off of just that, it's very unlikely, okay? Now, we're going to do the exact same kind of setup here, and I'll show you how we do this in Stata. But instead of one sample mean, a lot of the times what we're interested in, and we'll eventually get to regression today, and we have better ways of doing this, but the first look is, let's say I wanted to know the average GPA of an econ major relative to, I don't know, anthropology major, right? I think there might be a difference, okay? Well, what's my sample mean there? I've got two groups. So what we're going to do, we're actually going to have a different statistic. Let me make sure I line up with the notation I used in the slides just to not confuse anyone. I think I used D bar. I didn't even use anything, so it's okay. So here I'm going to call this D bar. This is like my sample difference. What is so that's the sample statistic I'm interested in. I would also have a standard deviation associated with that sample statistic. This looks very similar to what we're doing with sample means. However, this sample difference is going to be that average GPA I find for my econ majors minus the average GPA I find for my anthropology majors. Now, to keep this more general, right, this would be like group 2 and group 1, okay? So now I'm not thinking about the distribution of my sample mean, but I'm thinking about the distribution of the difference in my sample means. Okay, so to just keep it general, I'll keep this as 1 and 2 instead of econ and anthropology majors. But that was, I'm setting it up to think about this. So what we're going to do when we test for differences in the means of two groups, if I just want to know, is there a difference? What am I going to assume the true population difference is? So what we do with these, if we forget, kind of going back to 370, when we make these assumptions, we always try to stack the deck against ourselves. So if I think that there's a difference between anthropology and econ majors GPAs, I'm going to start out assuming that the difference is equal to what would be the opposite of that. If they were exactly the same, this difference would be 0. So I'm going to start out assuming, and this is what we're going to do with linear regression, everything pretty much for the rest of the semester, we're going to assume there is no difference. We start out stacking the deck against ourselves, right? Assuming that the difference is exactly equal to, so that kind of mean difference, we're assuming it's equal to 0. Then if we find a sample difference, let's say somewhere out here, well, let me use red, right? What I'm next going to do is I need to turn that into what? So I took my sample mean and I turned it into a, first of all, I had the letter. This is what? T. This was a t-value or a test statistic, right? So how am I going to turn this sample difference I found into a test statistic? It's going to be very, very similar, right? So what I'm going to do is to calculate my test statistic. I no longer have a sample mean. I'm looking at the difference in my sample means. I'm going to then subtract the assumed true difference, but here my assumed true difference is always going to be 0. So I can kind of ignore that, right? So I'm subtracting this assumed true difference. And I'm dividing by the standard deviation of the sample statistic I'm interested in. Well, the sample statistic I'm interested in is the difference in sample means. So how am I going to find that standard deviation for that difference in sample means? Well, if you go back to 370, anytime you kind of just have two populations, to get the variance of a difference, you would just take the variance of each group and divide it by its sample size, right? So just like what we had before, it's just now we have two groups, right? So this incorporates the variation that exists in econ majors and in anthropology majors, right? So it's the same setup though. Sample statistic, subtract the assumed true value of the population statistic. Here it's just easy because it's 0. Divide by the standard deviation of that sample statistic. Well, here our standard deviation is a little more complicated because we have to add in kind of what that sample or that variance would be for each group. But once I get everything plugged in here, I've now got my test statistic. Everything's exactly the same. I'm just looking to see, is that test statistic in my rejection region? Or to generalize this, in case we saw something down here, well, there I'm dealing with negative values because we know if we turn the mean into a test statistic, it would be 0. We said the general form is we reject as long as the absolute value of our test statistic is greater than the absolute value of these critical values. Okay. Everybody with me on this? Any questions? Get this out of the way before we keep moving. And I'll show you how we can do this very quickly in Stata. Okay. Questions? Did you guys do this in like 370? Did you do difference in groups? I don't know exactly how far they go. Probably not. They should have, but I do when I do it. I teach in the summer. But here it's really the same format of what we've been doing.
I kind of saw this differently in my recent class, but just to clarify, the square root of sample variance squared over the number of
Sample size.
sample size Could you also write that as, the standard, deviation squared over the square root of the sample size?
The standard deviate. Yeah, it's a good question. Hold on to it for 1 second. Any other questions on that before I go to his?
So in this case, our assumed difference is 0, but are there any other cases?
So for the sake of what we're gonna do, always gonna assume that that difference in the groups is 0. You could do it for, basically I could say, is the difference in econ majors GPAs more than 0.5? Or is it anything different than 0.5 or different than 0.2? I could use any value there. We're just gonna keep it at 0 for what we do in state. It'll make it easier, okay? Now to your question, any of this, it gets a little bit tricky because if I'm dealing with just a sample mean, how can I rewrite this? So this is the standard deviation of my sample mean. I could rewrite this as, well, the square root of something squared is itself. I could use it like that. Now, can I do that over here? Well, it doesn't quite work the same way, right? Because when I take the square root of the sum of something, I can't, like, that doesn't cancel out, right? So I can't rewrite this sample difference standard deviation the same way I would for one population, right? Just by the law of what a square root is. Is that what you were asking?
Yeah.
Yeah. And sometimes in the slides, I might even use this format, and we'll kind of see why from our state output. Okay. All right. So we've got these differences in means. We're waiting, we're waiting, we're waiting. What did I do? It's on desktop PC. So what does it not like? We'll go back to the dot cam and see if I accidentally hit something. So now it just doesn't want to work. That's always fun. All right, why would that be the case? So it's not picking up anything. That's telling me that this guy. So this guy. All right. Why it's doing this? Let's try this here. Otherwise, this might be a interesting class. I can't really show you a whole lot. I can get my laptop out here, I think, but I don't know if it's going to pick my laptop up because it's not picking this up. It just shut out, right? As I was like trying to go back to the thing, so that. "22 seconds. Let's hope it works." Looks like my projector's turning back on. Hopefully. All right. Crisis averted, right? So, here we talked about the differences in means. We're going to go to Stata, and I'll show you how we do some of this in Stata. Grab these p-values very easily. So one thing that we talked about last class, and I've really only kind of mentioned this, is we rejected when that test statistic was greater than our critical value. We said the flip side of that coin is I can compare the area that's more extreme than my test statistic. And then for a two-tailed test, take that probability and multiply it by 2. That tells me my p-value. That was the probability I saw the sample evidence I did or anything more extreme. I can compare that to what? So remember, when we're comparing these critical values, these critical values correspond to what? Different alpha values, right? So if I compare my critical value to this test statistic, that test statistic I can use, I can find the area that's more extreme than it. If it's a two-tailed test, it was equally as likely for me to find something on either side, multiply it by 2, and this gives me my what? My p-value. So I can compare the critical value to the test statistic. Anytime my test statistic is larger than my critical value, what's happening to this area? My p-value is becoming smaller. So the other thing I can do is I know that I reject as long as that p-value is less than these alpha thresholds. Now, this will be what we use a lot this semester because Stata gives us p-values for like everything. And technically, I was using like the standard normal distribution last class when I showed you how to look up a p-value and find the area to the right and then multiply. But for every different sample size, technically I shouldn't be using the standard normal. I should be using a different student t-distribution. Stata has all of that stored in behind the scenes, and it can grab it from not just the standard normal, but the actual student t-distribution. Okay. So let's take a look. I think here, I've still got this in the review of statistics file that we've been using. So we'll go down here. I'm going to set, I think this is going to be the wrong global. So I'll, for the first time, so once again, I talked with the other instructor who's a graduate student and having maybe some difficulties with things. So I know file paths are tricky. I'm going to show you, reiterate again, the easiest way to, I don't know what my file, I don't think this is going to be the right one. I think this was using, in fact, we can see if it's the right one. I don't think it's going to be. Yeah, it's mad at me, right? So I have this XLSX file or an Excel file. Here, I think it was under week 2 because we didn't quite get to it, but election data. So that should be in your OneDrive folder. So once that's in your OneDrive folder, you can go to File. Now, it's not a .dta. This is like the last time that I'll have to import things, but from in general, I'll give you the actual Stata file already. But even if you had to import, let's say you go out and you find some Excel data and you want to play around with it. I go to Import. I've got an Excel spreadsheet. I'm going to browse. I think I put it in, maybe it's in week 1. There it is, election data. I'm going to go to Open. Now, with Excel files, we have some other options. Notice here my variable names are in the first row. So I usually want to make sure that's selected. You don't want to select this second one. It turns everything into text, even numbers. So that just makes a headache for you. So we'll just have that selected. We'll hit OK. Actually, I lied to you. The other thing I want to do is this Excel spreadsheet has multiple. So this workbook has multiple worksheets, right? I want to use this non-missing one, and then I'm going to hit OK. So what this will do, unfortunately, I didn't have it very big, so it's going to put it on different lines, but it kind of tells me the code I would need. Well, where's my file path? My file path is my OneDrive or my iDrive, all these different folders. I don't include the name of the file. The file path is just where the file is. So I go up to right before the file name. I'm going to copy this. And for you, like moving forward, I would just create an E371 folder on your OneDrive. That way your file path is always the same. Don't create a bunch of subfolders because then you have problems like I do. And I forget exactly what subfolder I put things in, right? So here I've copied that file path. I'm just going to paste it, right? This global path, that's the same command all the time. Now, because I pasted it from this thing, oh yeah, I put it on different lines. So I kind of have to like get rid of those, right? So I had to kind of get rid of that. Also notice it through my quotation mark down here. I have to make sure that, right, that file path is all kind of looking like it's red. That's how it identifies this is like the text I'll use. So now it'll set my global so that I'm always working off the same folder, okay? I'm then going to open up this data. It's basically the same exact code that it ran if I did it from the interface. You don't have to do it. You can do it manually every time if you want to, right? So I'm going to go run this. Now, sure enough, it opens up that data file, right? Because I had the correct file path in here. Now, this data set has a bunch of different variables. So there's a bunch of 2020 election data. Some of the variable names are kind of wrong. I forget where I downloaded this from, but like it says percentage. Are these percentages? No, these are proportions, right? So, you know, you might have some weird things going on in your data set. So I think one command I haven't shown you yet is I looked at these variables and I was like, well, I know these aren't percentages. Also, it's just easier to deal with smaller variable names. And I kind of could remember what they represented. So we have these rename commands. This is just that I can rename a variable to make it something that's a little bit easier for me to type every single time. So instead of percentage 20, which was 2020, Donald Trump, I'm just going to name this Trump 2020, right? What that'll do when I run that code is it just renamed that variable to something a little bit more nice. You don't have to do this, right? It just makes it easier, makes your life easier. So I'm going to rename these as well. So this was, well, sorry. So if I try to then run this again, this is another point I want to make in Stata. If I rename a variable, it now has the new name. So if I try to run that exact same line of code, I'm going to get an error. Why? Because this name doesn't exist anymore. I already renamed it. So you can't rename, you don't want to run that same line of code twice. You can only run it once, right? Once you rename it, the new name of the variable is Trump 2020. This variable doesn't exist in terms of the name doesn't exist. I'm also going to rename this other one so that I have Biden's proportion of votes in 2020. And I believe this was at the county level. Okay. So, you know, I might look at this and say, okay, I can see the proportion of people that voted for Trump or Biden in all these different counties and different states. I'm going to take a sneak peek at this unemployment variable. So I'm thinking, you know, maybe places that had higher or lower unemployment, right? Maybe they would have been more likely to vote for Trump in 2020 because who was the pre-existing party that was in power? Not the Republicans, but Democrats, right? So if my unemployment was high in my county, maybe I think things are bad, I might be more likely to vote for the other party. So I was thinking, okay, let's look at this distribution of unemployment. First of all, so all that is using this hist command. This will give me a quick, there it goes, somewhat quick if we're not in Wi-Fi in Valentine, kind of idea about like, what is the distribution? So it creates a histogram. What does that distribution of unemployment look like? It looks like the average is right around what, 6-7%. Some counties had like really high unemployment. Some had almost no unemployment. Yeah.
So will there be commands to say that's like, you don't want to think of you doing the paper like.
Yep, that's where I'm going, but I'm trying to go slow, basically. But yeah, we're getting there.
It keeps saying, %20 Donald Trump doesn't exist, and I didn't rename it yet. And I'm looking at the like file, and it says %20 underscore Donald Trump, but it won't let me rename. Yeah, it says.
So did you make sure you're downloading this non-missing file or non-missing folder? There might be like a space or maybe it's not capitalized. It's case sensitive, right? So I uploaded this data set. So it should be, you should have the exact same thing I'm working with. If it, for whatever reason, doesn't, you can look in the data and see what it's called. If you use the actual name of that variable, it'll be able to pick it up. Now, if you ran this whole code already, you'd already renamed them, then it's not going to work.
Yeah.
Right?
I mean, copying and pasting it from the data set saying it's not there.
So we'll talk after class. I can't troubleshoot every error in class. I can guarantee you, if you spell the name correctly of the variable in the data set and you use this syntax, it'll be able to identify and rename it. Right? So like I said, maybe, I don't know, you hit a space on accident or something, but if Is anyone else having this? Are people getting this to run? No?
It ran.
Yeah, it ran. Yeah. So I don't know exactly. Maybe you're doing something wrong here. Maybe you didn't use this. Oh, I bet I know what you did. This is also where I shouldn't spend this much time in class to do this, but you probably forgot to select that thing where it treated the first row as variable names. So all your variable names are probably just blank. Try that. That doesn't work. Let me know, but I'm guessing that's what it is. Just off, I just realized that's probably what it is. All right. So to your point, we're trying to get to this difference in means. So I look at this unemployment variable and I have this idea. Okay, I think there might be a difference in the proportion of people that voted for Trump in high versus low unemployment rate counties. What's one way I could identify high versus low unemployment rate counties? Counties that had an unemployment rate above the mean. Well, we already talked last week, right? Maybe it was last class. I think it was last week. How do I create a mean? I can use this ECON function, and I want to create whatever the unemployment rate mean is, and it's just equal to the mean of this unemployment rate variable. Now, what that will do, right? I don't really need this anymore, is it'll create a variable that just puts in whatever the mean of the unemployment rate was for every single observation. Okay. So what I can now do is say, it'd be really cool if I could create a variable right here that was a 1 if this county's unemployment rate was above the mean and a 0 if not. That way I could identify what counties had above or below the average unemployment. Well, I can do that, right? So here in the second line, I'm creating this new variable called high unemployment. Now, if you use this gen command, you create a new variable. If you put a conditional statement, so when I say conditional statement, this is like x greater than y, x equal to y, x less than y, but we're using variable names. So what I want to do is say, if this is true, so whatever I put in parentheses, if this is true, so if the unemployment rate in that county is above the mean, right, which is this new variable I created, put a 1 in for this variable. So this high unemp variable will be what we call an identifier, like an indicator variable. It's a 1 whenever this is true. Whenever this isn't true, which would mean the county has what? The mean unemployment or less, the value that will get put into this variable will be a 0. So I'm going to run this, and I can kind of verify, right? So this unemployment was below the mean, I got a 0. Below the mean, 0. Anytime it's above the mean, even if it's slightly above, this variable is a 1, right? So I now have this variable that allows me to identify the difference, right? The two groups, high versus low unemployment rate counties. Okay. Yeah.
What's the difference between?
Yeah. So eGen, notice there's a blue thing here, a blue word. That's a built-in function behind the scenes. It's telling Stata calculate a mean. How do you calculate a mean? There's an actual process that's coded in behind the scenes. When I just want to create a variable, like without using a built-in, like this is just using a conditional statement, and I don't have to use eGen. There's no command I'm trying, like pre-stored. This is just how I would like kind of do more general math. I'm not using a built-in function here, right? So as we kind of do more things, it'll become more obvious when we use eGen, when we don't. If you ever get an error, just try both, right? I mean, it's not the best way to do it, but if you are getting an error, try doing the other one, and sometimes, oh yeah, I don't need that here. Everybody with me up to this point? Is this making sense? Or are we on time? Okay. So I can use these commands. We've already talked about the sum command. So there's another one, which is tab. I usually don't want to use tab for continuous variables. I would show you, but I'm afraid I'm going to break the computer. If I do, so what the tab command does is it shows me the number of observations for every individual response for that variable. So if I did tab unemployment, I would like to show it to you, but I'm afraid I'm going to break the computer because why? It would count the number of observations that had an unemployment rate of 0.01, 0.011, 0.012. I forget what decimal it stops at, but it would like show me every single possible. That's going to be a huge list. It's going to take a long time for it to do that. Now, if I have indicator variables, what would this tab do? It would tell me the number of observations that this high unemployment rate is equal to 1 and the number of observations where it's equal to 0. So with these indicator variables, it's actually kind of handy. So what is it telling me? What percent of my counties have a below mean unemployment rate? So what percent of the county? So when will that variable be equal to 0? When the unemployment rate in the county was below the mean. So what percent of the observations or the counties have below the average unemployment? 55%, right? So part of what we're going to be doing in this class is running the code to get some state output, but you still have to be able to interpret this, right? You can't just give your employer a bunch of code and they're like, well, I don't know what these numbers mean, right? So that's one way of doing it. Now, another way of doing this is if I have an indicator variable, I can also use the sum command. Now, it tells me the same information kind of in a slightly different way. So if I just have a 1, 0 variable, when I add up, when I calculate the mean, what am I doing? Adding up the value for every observation. So what would my numerator actually be? Well, every time there's a county with above average unemployment, that's a 1. Every time it doesn't, there's a 0. So well, my numerator would represent what? I'd only be adding up counties that have 1s. So I'd only be adding up counties that have above mean unemployment. So if I have the numerator is the counties that have above mean unemployment, then what do I do to calculate the mean? I divide the sum of that by the number of observations. So the mean of a 1, 0 variable is essentially telling me the proportion of the observations that were equal to 1. What would that be in percentage form? What did I get up there? 44.88, right? So either way really gives me the same information there, just in a slightly different way, okay? All right, any other questions before we keep moving here? I'm not going to explain this one too much. I just did the exact same thing, but I created this low unemployment. So if I do this and it's like below the mean, you could do the same exact thing. The numbers are going to be very similar, right? It's just going to be that now the 0s are 1s and the 1s are 0s, right? But I think it was easier to talk about the next thing that I want to do if I use this low unemployment rate variable. So what I can do as a very first kind of quick snapshot, and this isn't like a great way, but I can kind of look at by this variable. So if I use this by sort command, whatever I tell it to by sort, it says by this variable for the different values of this variable. So the only time you really want to use this is if you have an indicator variable, right? Technically, you don't have to, but for the sake of what we're going to be doing right now, just when we have a 1, 0 variable. So what this will do is it'll summarize this Trump 2020 variable when low unemployment is equal to 0 and when low unemployment is equal to 1. That's what that by sort command does. So we'll kind of notice here, our first glimpse is, okay, for counties that had low unemployment, actually, this kind of went against what I would have thought. The proportion of people that vote for Trump actually was a little bit what? Higher, right? So counties where things were actually good actually tended to vote a little bit more for Trump in 2020. I wouldn't have expected that, but that's what the data is, right? Now, I can also use this by sort command when I'm creating variables. So I'm going to create a variable that basically calculates the mean of two groups. It's going to calculate the mean proportion that voted for Trump in 2020, but for low unemployment counties and for non-low unemployment rate counties. So if I do this, the only issue is, so it runs this, I now have this variable. Notice it looks like it's all the same, but that's because all of these were low unemployment rate counties. This is the mean for low unemployment rate counties. As soon as I get to observations, and when I do the by sort command, it's kind of annoying. It sorts the data as well. But notice here, when I get down to the group that is 1, the low unemployment, well, there, that group's mean was a little bit higher. So where's the cutoff here? We can kind of see the difference. Oh, right? So it took every observation where that low unemployment rate was 0, calculated the mean just for those observations. Took every observation for that low unemployment rate variable that was equal to 1, calculated the mean proportion of votes for Trump just for those observations. Okay. So I've got the difference in means here. Well, what were we talking about before we got to Stata? The difference in two groups, means, right? So we're getting closer to what we want, but we don't have any test statistics here. We don't have any p-values. We need to go a little bit further, right? I don't know. I've got another example in here where you can do this by like high versus low proportion white. I thought that might be interesting. So I did like if white was above 80, which was like 80%, I did high income. So we can kind of take a look at the income one just because it's kind of interesting. So notice like counties that had high incomes, and I don't know what value, I chose 75,000. So these are like really wealthy counties. Those really wealthy counties, the proportion of people that voted for Trump, much higher than these counties that weren't, right? This was high income and high proportion of white. So what I did here was, sorry, I forgot. I created an identifier for if it had more than 80% of the population was white, created another indicator if their income was above 75,000. Now, one thing that you can also do when creating these variables using conditional statements, so I can say, create this variable, high income, high white, essentially county, which is equal to a 1 if this is true. I don't have to just do one thing. I can do multiple things. So here, this is going to be equal to a 1 if the income being high was not equal to 1, right? Or if white high was equal to 1. So I can do any combination of these. I think the way that I have this, I actually wanted it to both be equal. So I think I changed this because I wanted to remind myself to show you some different things. So this vertical line, you would read as or. If this is true, or this is true, right? If I wanted to say, create a variable that's equal to 1, if this is not true, that's where I use this exclamation point equals to sign, okay? So the syntax that you'll use if you ever want not equal to, there's not a not equal to sign on your keyboard, you would use exclamation point equals. That's not equal to. If I wanted to create this, if this is true and this is true, instead of a vertical line, I'll just use my and sign, right? So I think here, what do I actually want? I want if income is high and if they have a high proportion of white, right? So the problem is I already created this variable, but I created it incorrectly, right? So what's a good way to get around that? Instead of running my entire file again, a real nice quick way, and usually I wouldn't type this in the do file. I would probably just go to the program and type it in here, but just so we have it kind of saved so it doesn't go away. I'm going to drop, and notice it starts to like AI auto fill in what I'm going to just drop this variable because I want to recreate it, okay? So I'm going to go here now. Now this should represent when the income has high income and has a high population white, right? Another thing I can do, so before I keep going, any questions on that? So you generally don't want to use this drop command because it gets rid of the variable, but it's a way that you can kind of rewrite a variable. What I would probably suggest to do, although I don't want to throw too many things at you, and I know we've already talked a little bit about, or the drop command seems easy. When you use this gen command, you can also add in onto the n, comma replace. And then if you ever want to make any edits, so let's say maybe instead I want this to be if this is true or this is true. If it either has high population, white population, or high income, well, if I put this comma replace command in there, it'll essentially drop it and then recreate it. Well, let me see. What did I not do here? I should replace that. Why is it not? Oh, never mind. Why does it not like that? No, I'm going to see if I can remember the syntax without an observation. I think that actually might only work for my egen command. Sorry, I lied to you. That won't work for this command. I thought we had an egen command. We only had a gen command. For the egen commands, you can kind of put in a comma replace and it should kind of kick it out. But if you're only using gen, that's where you're going to have to kind of use this where you go back and drop it. Or you could just start from the top and rerun again. It's just a lot of times you probably don't want to do that, right? So I've got this high income, high white population county. Once again, I can kind of summarize this and see there's a pretty stark difference in the proportion of people voting for Trump in high income, high white population counties versus those that aren't, right? Might go against what, you actually thought might be the case, right? High income, high population, high white population, actually a little bit lower likelihood of voting for Trump in 2020. Now, we're not controlling for a lot of other factors here. We're just looking at, a snapshot. But that's how we can look at like find the differences in the means. Statistically, how do I want to start to actually run these hypothesis tests? So if I ever want to calculate, and this is like the last 3 questions, I think, of that first problem set. So hopefully you've started that problem set. I said started early. At those first 6, 7 questions, we've already covered even before last class, most of it. The last 3 questions, I think 3 or 4, like maybe part of the one, using some of this t-test stuff. So if I use this t-test command, what I first tell is, okay, what variable am I wanting to test for the difference in the means? So for us, this was there a difference in the mean proportion of people who voted for Trump in 2020 across different groups? What are those groups? Well, the first one, I just wanted to know low versus high unemployment rate counties. So by this low unemployment rate variable I created, that had 0s and 1s, so it kind of created my 2 groups there. Low unemployment rate counties and those that weren't considered low, high unemployment rate counties, right? Now, we're always going to use this unequal command at the end. This is because the way that we're not going to really go into it. You go back to 370 and they did 2 population stuff. If you have equal variances versus unequal, you can do things slightly differently. More often than not, we don't know. I mean, it's likely that the variances aren't going to be exactly the same. Maybe like in the physical sciences, there's a lot more examples where you're sampling from populations that should have the same variance. But for the most part, we're always going to assume we have unequal variances, so we need to have this added in here. Okay? So if I run this code, what am I going to end up with? Kind of here's my output. So it's running a t-test. It's doing my hypothesis test. And in fact, it gives me multiple types. You have a left-tailed, two-tailed, right-tailed test. We're always just going to be thinking about, is there a difference between these 2 groups? So we're always going to be using this p-value. This is like the probability we saw the test statistic we did or anything greater. This is our p-value. It's already taken the area in one tail and multiplied it by 2. This is for a 2-tailed test. Now, I don't know why Stata does this. Notice it doesn't have an H subscript 0 here. If you go back to 370 and remember, we have a null hypothesis. The antithesis of that is the alternative hypothesis. It's the exact opposite. So I said we're always going to assume the difference was equal to 0. That was our null. So the alternative is always going to be that difference is not equal to 0. It uses the same syntax that you need to code in the output. Okay. So here, can I say that there's a statistical difference between the proportion of people in a county voting for Trump in low versus high unemployment rate counties? Well, that p-value is basically 0. So can I reject the null? Remember, tattoo this, right, on yourself or have it written on everything you do. All throughout the semester, we're always going to reject if that p-value is less than alpha. So what are our typical alphas? We said 0.1, 0.05, 0.01. Is a p-value of 0 going to be less than any of those? Yes, all 3, right? So I can reject at very high levels. If my p-value is 0, I can reject at the 99.999% level, right? So really low p-values are going to be evidence that there is a difference between these 2 groups' sample means, okay? We found pretty strong evidence, okay? Questions on that before we keep moving here? Okay. Let's see if I can remember this. I probably should have done this before class. If you go to statistics, I always code. This is going to show my very limited knowledge of using the interface. Statistics, summary tables and tests, classical tests, mean comparison t-test. That's essentially what I just did. we're always kind of looking at two samples using groups. The variable name we wanted was Trump 2020. That's what we were looking at the difference between. The group variable was the low unemployment rate. So where is that? Here it is down here. We said we're always going to assume we have unequal variances. We can actually specify what levels of confidence we want here. We'll just leave it at 95% for now. I can hit OK. I'm getting the exact same output. All right, so you can use the interface. I'm telling you that this is always going to be the syntax. Once you know what it is, to me, instead of going through that process every time, I can just copy, paste, and then change this to whatever variable I want to now test the difference between, right? So now I might say, okay, what's the difference between the proportion of people that voted for Trump in high income counties? Is there a difference? So all I do is change the low unemployment rate variable to that high income variable. Sure enough, there, I also get a p-value of 0. Now, I think I tried to choose one, hopefully. Well, oh, I added it down here. So all of these are 0, right? And that's because I tried to choose things I thought might cause a difference in the mean of proportion of people that vote for Trump, right? Or in that mean, right, was going to be different between high income, high white, low population. I had this variable that existed, which was the mean commute time, right? I was like, I don't know. Should that be related to the proportion of people that vote for Trump? Maybe there's a story that you're less likely to be in a big city or something, but let's try that, right? So I'm going to summarize this variable just to get an idea. Okay, the mean was about 23.47. I'm then going to create this 1, 0 variable. Once again, how do I do that? Put a conditional statement in parentheses. So every time the mean commute of a county was greater than 23.4, which is about the average across all the counties, I'm going to put a 1 in here and call that long commute, right? You have a lot, more than 23 minutes to get to work every day. Anything that doesn't meet that criteria gets a 0. So I'm going to create that variable. I'm then going to run this t-test command. Once again, I literally did this yesterday. I copied, pasted this down here, changed this word to my new variable that I created, this indicator variable of long commute. Okay. If I now run this, right, what's my p-value? 0.22. So can I say that there's a difference in the proportion of people that voted for Trump in counties that had above average commutes versus those that don't? Well, is that p-value less than any of my 3 conventional benchmarks of 0.1, 0.05, or 0.01? No, I failed to reject that every one, right? I can't say that there's a difference in the proportion of people voting for Trump across counties that have long versus short commutes. And that kind of makes sense. I don't know why that would, well, once again, there's a convoluted story about it's correlated with being in a big city and things like that. But here we found no evidence that there's really a difference, okay? So these t-tests, right, running this difference in means, that's the last thing you should need for that first homework assignment. So you should have everything you need to do before we meet in class next Thursday. So you got a whole other week, office hours next week. Make sure if you're having questions, you stop by. Hopefully you've started it. I've tried to reiterate that, but now you should have everything you need to kind of complete that, okay? Any questions over anything I just did? You want to go back, or what if I change something? We're hopefully feeling a little more comfortable with this. Yeah.
So if you want to view it, can we just run the code again?
You want to do what?
Review what you did last.
Yeah. Yeah, you would just run it up to whatever line you wanted to look at the output of, and it'll give you that output every single time. Yep. Yeah.
Just for the scatter plot question, you want
Mm.
to insert an image or just like the answer?
You don't have to include the image as long as the code's in there. That's fine. So in fact, we kind of talked about that last week, right? Creating those scatter plots. We've got the command here. Yeah, if you have to create an image, as long as you have the code there, I'm not super, you don't have to feel like you have to attach it, right? It's because you can't attach images to your do file. If you just want to upload a do file with comments, you're not going to be able to. As long as you have the code that creates it correctly, you'll be fine. Yeah.
I think you just said this, but just to make sure, we can just like add comments on.
Mhm. Yeah.
You don't have to.
You don't have to do a separate Word document if you don't want to. In fact, sometimes for these first assignments, what I'll get people doing, and you don't have to do this. Let's say I asked you about whether or not there was a difference between counties with long versus short commutes and the proportion that vote for Trump, right? I don't want you to like copy and paste the output into a Word document. I know what that output is going to be as soon as I say that code. I guess if you really want to, you can. I think some people, it does help them kind of organize their thoughts if they do want to use the process of writing my code in a do file, putting all of my answers and written stuff in a Word document. It sometimes helps people to kind of copy and paste that over. But the formatting gets weird, and I don't need the output, right? All I need is the code. And if I ask you questions like why, or if I do ask you what is the mean, just because you give me the code, here's a good one. Let's say I asked you, is there a statistically significant difference in the counties with a long versus short commute? You can give me the code that tells me this. That does not let me know that you know how to find the p-value and what that p-value tells you. So you can have the code that's not of a complete answer, because you then need to look at this output and tell me the reason why there isn't a difference is because the p-value is greater than our benchmark elements. Right? So you don't have to copy and paste the output, but when I'm asking you to do something with the output, I'm asking you a question about it, you need to give me a response to that, right? So a lot of the times you will be referencing values that are in this output, but you don't actually need to copy and paste the full state of output in there. Am I being clear when I say that? Any questions or any clarifications anybody wants on that? Once again, this class, you're an economist, pretty large fixed cost in the first few weeks. Once we get going, the marginal cost of what we're doing in Stata, right, it starts to get lower and lower, right? But there is a pretty big upfront fixed cost, okay? This is how I think about the world. So I put this in at the end. This is just something that maybe moving forward, I forget to do. I will try to remember. I gave you this data set. It had a bunch of variables that we didn't need. So when I'm looking at the data, instead of scrolling back and forth all the time, if you can kind of see, I'm not going to need some of these variables. You can also use that drop command, right? I used it earlier to like drop one specific variable. Where is it at now? Somewhere right here. You can drop all these other variables that you don't really need. Now, I didn't type all of these out. What I did was, you can kind of go up here. So let's say I go to men, all the way down. I don't need any of these. I right click, go to copy variable list. So that's one way. If I want to do things with like multiple variables, I can copy all of those names at once. I'm then going to say I want to drop and paste all of these, right? Now I can kind of, if I drop all this, oh, cool. I now have a much smaller data set. I don't have to do as much scrolling. Now, once I drop those, they're gone. So if I ever want to get those variables back, I have to go back and open up the original file and kind of do everything again. But if I know ahead of time, like I'm not going to use any of these variables, you can use that drop command. That probably won't really apply as much to what we do in class. But if you're like going out, like, I don't know, if you're interested, like you could go out and grab a bunch of stock market data if you were kind of thinking about wanting to try to make predictions and, I don't know, trying to anticipate what different sectors or, if you get really ambitious, you're probably going to have data sets that have a lot of variables you don't want, and it just makes it annoying. That drop command becomes pretty helpful, right? So I try to drop things in sometimes into this state of work and do files that like aren't as applicable to what we're going to be doing. You probably shouldn't be using the drop command a lot in this class, but if you're going out and getting your own data, that's going to help you kind of clean it, right? But yeah, it's a bit of an aside. Any other questions kind of here before we keep moving? Yeah, 15 minutes left. So I thought we'd get, once again, it's okay. We'll start linear regression next week, or I might kind of introduce it here just a second if we have time. But the quiz is definitely going to be something that we have not covered what I wanted to, so it's okay. So what do I want to do here? We've got 15 minutes. I'm going to publish this quiz. Give this a little bit of time to get this opened up. And at the very end, maybe I'll just give you the answers, right? So instead of using this on Tuesday, I kind of told you I'd give you two today or two this week. And we'll kind of have those answers to kind of go back to when we talk about it after Tuesday's class. So before we get to that though, and to give people kind of time to open that up, the other thing that I wanted to work through, so we did all of our stated work, we'll start regression next week, but there are some things that I wanted to, and I might even start talking about it today, we just won't get very far. I wanted to start to think about some of these things that are going to influence my rejection decision because we're going to talk about them with linear regression, okay? So let's say I'm looking at, we could even do these like sample differences examples, right? So here, let's assume I see some sample difference, right? I'm going to turn that into a test statistic by subtracting the assumed true difference. We're always using 0. That's easy. And I'm dividing by the standard deviation of that difference, which was just the variance of each group over the sample size. So Stata is calculating this behind the scenes every single time you use that t-test command. It then, based off of these sample sizes, knows which student t-distribution to use to calculate your p-value. So you don't have to use the physical tables. You get to avoid all that stupid stuff, right? It will then spit out at you, and here it didn't actually give us test statistics. For regression, it will. But for us, it calculated a test statistic and then calculated ultimately our p-value. Now remember, that wasn't the area just in this tail. We were doing two-tailed tests, so it took that area and multiplied it by 2. Okay. So let's start to think about the things that are going to make it more or less likely I can reject whatever the assumed true value is for any statistic. So for right now, we're looking at the difference between sample means. The same principles are going to apply when we talk about sample coefficients next week with regression. So let's think about the first thing, right? If the variance of either of these groups increases, right? What's going to happen to my test statistic? So if these variances go up, what's happening to my denominator? So if my denominator is larger, what happens to my test statistic? If my test statistic decreases, what happens to my p-value? The area to the right of it is becoming larger, so my p-value is going up, right? So if my test statistic's going down, my p-value is going up, which means is it more or less likely I'll reject the null? We said we only reject if that p-value is less than alpha. So if my p-value is higher, is it more or less likely I reject? Yeah. If this is when I reject, when my p-value is higher, it's less likely it's going to be less than alpha. So high p-values mean it's less likely I can reject whatever I assume that sample difference was, or whatever that difference in the groups was. Any questions on that before I keep going here? What if, well, I might have enough room here, and then I'll move it over. What if instead I found the exact same difference, but I did so and I had larger sample sizes? If I have larger sample sizes, so before we work through the mathematics, just intuitively, if I find the same difference, but I found it from, instead of like comparing 10 people from each group, I had 10,000 people from each group, which of those do you think is more informative about if there is a difference? Well, with 10 people, what could be the case? I end up with an extreme outlier. With 10,000, if I end up with that outlier, does it matter as much? No, it's getting averaged out across 10,000 people. So intuitively, if I have a higher number of observations, should it be more or less likely I can reject the null? More. It should be better information. Well, we can walk through why. If my sample size goes up here, what's happening to this fraction? this fraction would be going down. If my denominator is smaller, what happens to this fraction? My test statistic is going up, right? So my test statistic is going up, which means what's happening to my p-value? Smaller, which means am I more or less likely to reject? More likely, right? So we don't really have a lot of influence over what the sample variance is or what the variance of data is. But what's one thing as researchers or as data collectors we do have some influence over? We can go out and get more data. Getting more data is always going to make it more likely I can reject certain values, right? And that's just because having more information, right? I'm getting closer to what the actual population is, right? It's not just a sample estimate now. It's the actual difference. Now, we don't ever get population data more often than not, but we're moving towards that. Kind of a tricky one. What's one other thing that would make it more likely I can reject the null here? So the statistic I was looking at was like this sample difference. If I find a higher difference between the two groups from my sample intuitively, am I going to be more or less likely to reject the null? So if I were to compare the econ anthropology majors and the difference in their GPA was 0.01, am I going to be able to reject the fact that there is no difference? Instead, if I had found a difference of 2.3, well, 2.3 is way further away from 0. I should be more likely I can, well, how does that work? All it's doing is, right, increasing that numerator, which increases my test statistic, which does what to my p-value? Decreases it, making it, if I can write, more likely I reject the null. Okay? So all of these three things, seeing different sample values for the statistic we're looking at, having different variances associated with that sample statistic, or having different sample sizes will all influence how much, more or less likely we are to be able to reject the null. Okay? And the same thing's going to apply when we look at linear regression next week. Okay? All right. Questions from me before we keep moving? So this should be everything, all the review for that first quiz, right? So, and that first homework assignment. So if we're going back, looking at Canvas, well, I have the quiz pulled up. Let's see. I don't really want to pull that away right now. So let's get to the home page here real quick. Maybe real quick. So we've got that first quiz. Where is it at? There it is, right? Which I have kind of set to be due by the 4th, right? So, wait, is that what I wanted? What is the 4th? 1, 2, 3, 4. Oh yeah, by the time we start next class. Yeah, I was thinking that was the 3rd for some reason. No, by the 4th, right? So that quiz, we've already kind of covered everything you should have needed to kind of answer that, even before today. So that's due by the time we start class on Tuesday. Had a little bit of stuff that we didn't cover that was needed to kind of complete that first problem set. So that's due by the end, not the end of the day, by the time we start class next Thursday. Okay. So that's the only kind of current things we have. The only other thing that we have today is this kind of in-class assignment. So I'll kind of give you guys the answers here. So if you're here today, you should be able to get full participation points, right? So this first one, right? I've even got it built here so you can see the answer is D, right? For this next one, the answer is also D. And then here, the answer is, this is the first option. I say D. I don't know if it has A, B, C, and D next to it for you. But the first one is for every additional 100 students, the GPA goes up by 0.01. Yeah.
Question 2 is C or B, not D.
So whichever answer is, so as I said, I think it might be set so it shows you guys different ones, since I was going to use it after we cover the material, but we didn't quite go as fast as I wanted to this week. Should be 10% only. So 100 students should be the option you choose, 10% only, and then more likely, right? We'll kind of notice having higher sample sizes, it's going to apply the same way to stuff we talk about next week. So I could have kind of asked you this one, except for instead of linear regression, if I have a higher sample size, what did we say that's going to do? It's going to increase my test statistic, which decreases my p-value, which makes it more likely I can reject the null. The same principles are going to apply when we move to like future topics, specifically even when we're talking about linear regression. Okay. All right. So if we're looking at the slides before we get too excited and pack up and leave, I'll probably go pretty quickly through a lot of what we have here. So we'll probably cover everything that's in these slides by the end of Tuesday's class. I'll upload like week 4, and I'm just going to like cut these out and kind of start with those and then put in the next kind of set of slides. But we're really going to start to transition. We've now got the review and the basics we need. We're going to start thinking about how we do regression. And even if you talked about Net 370, we're going to push those topics further. So I'll bounce back a lot more in future classes between Stata and the actual slides now. And I'll start to put in Stata output into the slides. But yeah, so make sure kind of have Stata working. That first assignment due before we meet in class next Thursday. That first quiz due before we meet in class on Tuesday. Have a fun, safe weekend, and I will see you guys on Tuesday.
Thank you.